The concept of concavity sometimes takes a moment to get your head around, so I'm going to start with that. I'm going to describe concave up 3 ways, and then we can start to move through this problem a little more quickly. So one of the first ways to define concave up is to say that the second derivative of the function is positive. Now, if you're familiar with derivatives, that's great. It's an algebraic way of going after this. But it's sometimes hard to measure what the second derivative of a function is if you don't even know what the function is. So I'm going to move on to the second way I've defined this, where I said the slope is increasing. Okay, that might be a more helpful way to define it in this graph. So if we look at this graph, I'm going to pick on a few points over here. Let's just pick on this point and this point and this point. Okay, and I'm going to say what the slope is for each one. Now, obviously, I'm just guessing. But let's say for this one over here, the slope is, it looks negative. I would say, you know, if I imagine a line going that way, tangent to that point, it's a negative line. So I'm just going to guess and say that slope is -2. And then over here, I'm going to say, well, maybe this one has a positive slope, but only just barely. Let's say that slope equals 1/3, right? Because if there's a tangent line there, it's increasing very gradually. So, and oh, I forgot this one over the way on the left. That would be a very negative slope. That would be like slope equals, I don't know, -5. It looks like it's going down pretty fast. And you can see as you go left to right, these numbers for the slope, -5, -2, 1/3, they're increasing. So that what that means is this whole region right here is all concave up. So the question is, well, how long does that pattern continue? And if you go off to the left, you can see, well, this is only getting more and more extreme as you go off to the left, right? It's getting steeper and steeper and steeper, which means if you imagine a point up here, this would be like slope equals, who knows, -10, maybe. So it's -infinity on that side, right? And then how far do we go before the slope is not increasing anymore? It's a little hard to tell, to be honest. Let's come up with a ballpark number for this one. Let's say slope equals, I don't know, +2. Looks like it, could be. And then by the time you get over to B, so I'm going to draw a red line because it's getting a little cluttered now. So here's my slope line right there. And by the time you get to B, you'll see that that line has actually decreased in its slope value. Okay, so clearly it's coming back down and we've entered a negative concavity region. But as far as the graph, sometimes you have to eyeball it a little bit and say, okay, it looks like the slope is still increasing here, 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 and then it probably stops increasing at this point and then turns around. So if they give you an equation, you can be very sure about it, but with a graph like this, you have to eyeball it a little bit. I'm going to say the slope is increasing, or the graph is concave up between -infinity and this x value of j. Okay, it's going from -infinity to j in a concave up region, and then probably from j to +infinity as a concave down region, right? If I wanted to mark where this thing is concave down, it looks like this is all slope decreasing, right? It starts out with a slope of 2 and then goes to slope of 1, and then by the time it gets up here, maybe it's at a slope of 0, like right there, and then it just goes way negative. So that's the slope idea. Another way you could do this is try to imagine a tangent line and ask whether the curve itself is above or below the tangent line. So I don't love that method. We're running out of time, so let's go into the other points of this graph. If I say increasing and decreasing, well, that's not complicated. That's just, is it going uphill or downhill? So I would say it's increasing right at the point where the slope equals 0. So I'm going to draw 2 tangent lines to where slope equals 0, right there and right there. These are the interesting points. And so we're going from H to M. And it's increasing between those. But everything else is downhill. So that would be like -infinity to H, and then union M to +infinity. Meaning it's negative, it's decreasing on the left side and the right side, but in the middle it's increasing. And then one last trick with the zeros of this thing, got to be a little careful with this. The zeros are just the x-intercepts, but we don't say them in intercept form, we just give the values of them. So that would be like G and K and P, whereas the y-intercept, you want to be very careful and make that a coordinate point. So that would be in this graph 0, comma b. Okay?